All right, friends, it's your boy, Mr. Shagney, coming at you with lesson 15 notes and practice problems for today on shapes on the coordinate plane. So this lesson is going to basically take us to the coordinate plane and ask us to plot shapes on the coordinate plane. And so we're going to walk through this. So 15 and 1/10 says figuring out the coordinate plane. It says draw a figure in the coordinate plane with at least 3 of the following properties. 6 vertices. So a vertex is where 2 line segments meet, right? So a vertex would be connected with 2 lines, right? And that's like a little edge there. 1 pair of parallel sides. These are sides that never intersect. At least 1 right angle. Right angle is 90 degrees, and so it should form like an L shape. 2 sides with the same length, so that means that you just have to have 2 sides with the same length. So I'm going to go ahead and draw my shape. So I have 3 points. That's 4 points. So that's my shape. It has 6 vertices, right? So 6 vertices are where 2 line segments meet. 1, 2, 3, 4, 5, 6. Where 2 line segments meet. It has 1 pair of parallel sides, so this side is parallel to that side. At least 1 right angle. There's a right angle right there. 2 sides with the same length. So this side is 2 units. This side is 2 units. And so it meets the criteria of that. Is your figure a polygon? Explain how you know. Well, characteristics of a polygon, we know polygons, so from this we know that polygons are composed of line segments. We know that in a polygon, each line segment meets one and only one other line segment at each end. Line segments never intersect. Never intersect each other except at their endpoints. And we know that polygons lay flat on the coordinate plane. Right, so that information can help you understand that the figure is a polygon as long as it meets this criteria. Remember, vertice, so I'm going to label these things for you. This is where 2 line segments meet, vertice, and I might have spelled that wrong. I usually do. 6 vertice. Parallel sides, so sides that never touch. So if you're looking, these are parallel lines, right? Because they're never going to intersect. Parallel lines. Right angle. Right angle is when you have an L shape, it can be upside down, it can be sideways. As long as it makes that L, I like to put L on my forehead to think about right angles. 2 sides with the same length, so that means that you're just counting the units, so 2 of them have the same length. We call that congruent in mathematics. Moving on to the next activity. So today, the next activity is called plotting polygons. So it says here are the coordinates for 4 polygons. Plot them on the coordinate plane. Connect the points in the order that they are listed, and label each polygon with its letter name. So polygon A, I'm going to start at -7. So -7 and up 4. 1, 2, 3, 4. That's my first point. -8, 5. 1, 2, 3, 4, 5. I connect those. Then -8, 6. -8 and 6. I connect that. -7, 7. There, and I connect that. -5, 7. 1, 2, 3, 4, 5, 6, 7. Negative, and I connect that. -5, -5. So -5, -5. -5, 1, 2, 3, 4, 5. And 7, 4. So I'm going to connect those two, and I'm going to go back to that point like that. So this is polygon A. Based off of the points that we had, that's polygon A. It should look like that. You can also label it 1. The next one is 4, 3. So 1, 2, 3, 4. 1, 2, 3. Then it's 3, 3. You're going to connect those 2 points. Then it is 2, 2. Going to connect those points. Then it's 2, 1. Connect those. Then it's 3, 0. Connect that. Then it's 4, 0. Connect that. 5, 1. Connect that. 5, 2. That, and you're going to go back to your original starting place. So this is polygon 2 or B, right? So that's the second one. Polygon C is -8, and then 5, and then -5. 1, 2, 3, 4, 5. -8, -8. Combine those two. -5, -8. -5, -5. And then you're going to go back to the beginning. So this should just look like a rectangle or a square. So this is 3, 3, it's really square. So that's the third one, or this is C. And then polygon D is -5, 1. So -5, +1. -3, -3, -3. Connect those 2 points. -1, -2. Connect those 2 points. Negative or 0, down 0, up 3. 1, 2, 3. So you're going to do that. And then -3, -3, or -3, 3. -3, 1, 2, 3. So it should go over, and then you're going to go back to your starting point. So this is number 4, or the last polygon. So that's what we're doing. We're basically putting a shape in the coordinate plane. And so things that you need to take away from this is you need to understand how is the coordinate plane related to the number line. And so the coordinate plane has 2 axes that are both number lines. So I'm going to write that. The coordinate plane has 2 axes that are both number lines. That's an important concept. And then how are we able to make the polygons in the coordinate plane? The vertices of a polygon are plotted as points in the coordinate plane. So the vertices of a polygon are plotted as points in the coordinate plane. That's what allows us to plot shapes in the coordinate plane, is that the vertices allow us to treat them as coordinates. And the last thing from this is that the coordinate plane actually allows us to assign numerical values to shapes in the coordinate plane, because I can tell you how long each line segment is based off of the units being used in the scale of the coordinate plane. So the scaling of the coordinate plane allows me to determine how large or how small an object must be. So keep that in mind. People that design houses and stuff like that use a scale for their drawings, but they also have that scale that's going to then become larger when they actually put it all together. And then we have our last activity today, which is 4 quadrants of a mazing, which looks like the maze that we did not too long ago. So it says, the following diagram shows Claire's route through a maze. She started from the lower right entrance. So Claire is starting over here, right? So this is Claire, right? Claire. She's starting right there in the maze. And then it says, what are the coordinates of the first 2 and last 2 points of her route? So I want to know the location of this point and this point. So remember, we have to understand. So remember that this is 0, right? Right in the middle is 0. So I'm going to put a 0 over here, and I'm going to put a 0 right here, right? And so I'm counting by, it looks like I'm counting, this is 2, 4, 6, 8, 10, 12. Yeah, we're counting by 2s again, just like we did last time. So I need to understand, right, what I'm counting by. So if I'm counting by 2s there, then this would be -2, -4, -6, -8, -10, -12, 14, -16. So this first point falls right on, it looks like that falls right on 8, right? So for y, and then for x, it looks like it falls on 10. So for the first point, I have 10, comma, 8. That's the first point. So where she starts, that would be number 1. So she starts there. Oh, 10, 8. Let's check that. So this is where she is. Oh, so 2. Is that right? 0, 2, 4, 6, 8, oops, 10, 12. I counted wrong. 14. So rewind this for a second. So back up for a second. So this is not correct, right? So I need to go back and look at this again. So this point here, right? That point, my x coordinate is actually on the 12. And my y coordinate, I forgot that that's a negative number, so that should be -8 because it's below that 0. So it should be 12, -8 for the first coordinate. And then for her second location, I'm going to draw a line down. That looks like it's on 4. And it's on the same line as the first one, so that this coordinate is going to be -8 for its y. And then I'm going to go to the last 2 places. So to exit the maze would be, this would be the next point I want to talk about. So if I go down, right, all the way down, I'm going to draw this all the way down to help me kind of visualize this. This would be -2, -4. So that's -4, and then I need to draw a line over, and then that's 2, 4, 6, 8. Interesting. -4, 8, and then my last point is going to be, I know it's going to be 8 at the end because it's on the same line. And then if I go all the way down here, right, that looks like it's going to be -12. So -12. So I apologize for the careless mistake I made. It was because my brain is moving way too fast. But you start here at 12, -8, then you go to 4, -8. Those are the first 2 points. The last 2 points, this is the opposite of that, right? So it's interesting how that works. And then this is the opposite of that. Both of the points are How far did she walk from her starting point to her ending route? Show how you know. So how far did she walk from her starting point to her ending route? So this is her starting point, right? And so if each square counts as 2 units, right? Then I know that this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. And I'm wondering if it took her 40 steps to get here, if it's gonna be halfway, like if I can multiply that by 2 to get the end point, but we'll see. 42, 44, 46, 48, 50, 52, 54, 56, 58, 60, 62, 64, 66, 68, 70, 72, 74, 76, 78, 80. Yeah, so 40 steps to the center. So 80 steps, or 80 units. So each square to the center, I'm going to say to the center, is 40 units. So I doubled that and got 80. Right, you could count to also get that answer, and so moving forward. So it says Catherine went to the maze and stopped at -7, 2. Plot that point and other points that would lead her. Plot that point and other points that would lead her out of the maze to the exit on the upper left-hand side. So I need to go back to the graph. This is, sorry, I have enough. And go to -7, 2. So -7 will be somewhere over here, 2. So where does that intersect with 2? So somewhere right there. We're gonna go up, 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 up. So that looks like 2 meets that line, and that's -7. So she enters the maze there. Now that purple point I just plotted. And then it says plot and point other points that would lead her out of the maze through the exit on the upper left-hand side. So plot other points. So she could go here, and then I'd say take that route, right? So I would just use 2 of the points already given to me and plot a new point. So this new point would be -4, +2, -4, +2, so we know that our route is -7, 2, and then 4, 2, -4, 2, and then from there we have this point. So I'm going to go back to so I plotted this point, and this point, remember we plotted earlier, this point is so 8, -4, or not 8, -4, but it should be -4, 8. -4, +8, and the last point out, the last point out is -12, because this one's -12, 8. Okay, and it says, how far from -7, 2 must she walk to exit the maze? Show how you know. Well, she's moving 3 units here, right? From this one to that one, she's moving 3 steps. And from this one to this one, she's moving, from this point to that point, she's moving a total distance of, let's see, from 4 to 12. 3 units, and then this is 8 units. So let's see, from here, this is -7, so that's 1 unit there, which is -6, and then we have 3, 5, 7, 9, 11, 13, 15, 17. So it makes sense that it's 17 step. So how many steps does she go? So she goes 1 step, 3 steps, 5 steps, 5 steps, 7 steps, for this one, I would say the difference between these two is, so the absolute value of -4 is 4, absolute value of 12 is 12, and you're just moving on that, so that's a subtraction problem, so that's 8. And since each step counts as 2, right? Okay, plot, so those are her points, and then how far from -7 to must she walk to exit the maze? So, to exit the maze, she's here, right? So how far does she need to walk? Well, I know that she's at -7 here. To get to -6 is 1 step. To get from -6 to -4 is 2 steps, so that's 3 steps. To get from here to there is 5 steps, 7 steps, 9 steps, 11, 13, 15, 17. I'd say it's 17 units. 17 units, and I counted each step. So I know that there's a distance there, and I was trying to do something there, but we're gonna have to fix that. 17 units, I counted each step. And then our exit ticket today, so I'm gonna have to do, our exit ticket today, plot the following points in the coordinate plane and connect them to create a polygon. So 1, 3, 3, 3, 3, -2, -2, -2, -2, 0, 0, 0, 0, 2, 1, 2, and then 1, 3, which is going to connect it. So I know that it says, what is the perimeter? Well, to find the perimeter, I know that that's 2 units. This is 1, 2, 3, 4, 5 units. This is 1, 2, 3, 4, 5 units. This is 2 units, 2 units, 2 units, 1 unit, 1 unit. So 5, 2, 5 and 5 is 10, 12, 14, 16, 18, should be 20. The perimeter is 20 units. Right, and so that is going to be our lesson for today. If you like this video, hit a quick subscribe, and I will see you all in class.